Okay, students, good morning to all. So, the today lesson we are going to be discuss about image compression in the digital image processing. We have to be discuss the earlier sessions, digital image processing fundamental, image enhancement, image restoration. So, followed by all these chapters. So, now we are going to be discuss about image compression. So, in the image compression, we have to be discuss the content. The first thing, the fundamental of the image compression, then some of the compression standard models and methods by using the information coding or information theory related with this one. Okay, so the name itself you have to be see the compression, the image compression, the name itself to give the meaning. We are going to be compress the image. It may be a two-dimensional or three-dimensional or whatever it may be. Now what we have to be do, going to be reduce the original size without affect the quality, without affect the existing attribute, the brightness or darkness or whatever it may be. The existing quality will not affect. We have to be reduce the size. Actually, the digital image that can be represented by using in the raw data bits, it require more number of storage space. So, in order to reduce the size, we have to be save the storage space as well as the speedy transformations will happen. So, we will see one by one. We have to be see one by one. So the image compression the contents what we are going to be discuss now, the image compression fundamentals. So image compression models, the elements of information theory, then error-free compression, lossy compression and lossless, then image compression standards. The image compression standards. So we have to be see one by one. So the image compression deals with reducing the amount of data that required to represent a digital image by removing the redundant data. So simply we have to be say that to reduce the size of original image without affect the quality, without affect the existing attributes, but we reduce the size. This size reduction, it is not a physical one, it is a logical one, because we are not going to be physically cut any portions of the image in order to perform the compression. Just logically we have to be do it. So the image can be represented in a digital format in different way. So whatever it may be, the thing, the first one, the ultimate objective, the digital image that should be represented in a data format, the binary format. If it may be decimal or hexadecimal, whatever it may be, we convert it into the binary format for our compression process. So the raw image representation usually require large amount of storage space and the probability of long transmission time also. When we try to transfer the image through the any communication channel, if the size is too much, if the size is long, the huge volume of data file or image file means it requires long duration for the data transmission or image transmission. So the ultimate aim to reduce it, the reduce the time or to reduce the storage space, we have to go for this compression method. This compression method. So the need to save the storage space and make it the shorten transmission time as well as the human visual system tolerance to a modest amount of loss have been driving the factors behind the image compression technique. That means whenever we try to transfer the file from one terminal to another terminal or one node to another node or one system to another system, we have to face the problem of data loss. So it affect the quality of the image at the receiving side. So what we have to be do, the image compression model, because of this reason, that will be broadly classified into two category, lossless and lossy. Lossless and lossy means based on the loss of the data, missing pixels. If the missing data is below the standard error level, because up to certain level, the tolerance level, so it will not affect the quality. So up to that certain level, that means the error below the standard error, then we accept it. Then the destination side we receive the quality one. Suppose the error rate is above the standard error means, then we go for the remedial action, how to restore the original image like that. We ignore it. We have to be ignore that transmission. So this is the reason here they use the word the human visual system tolerance. That means we fix some standard error. Below that error, there is no issue for the quality of the image at the time of decompress it. But above the standard error means there is a issue. There is a problem to get back the original one. So this is the meaning, this is the content in the image fundamental concept. Just you have to be look at this slide, the block diagram. The f of x comma y is the original image that we are going to be transferred through the channel. So that will compress it by using any one of the mechanism, because the compression mechanism has to be classified into many category: arithmetic compression, Huffman compression, LZW. So like that, there are so many options: discrete cosine transformation, whatever it may be. You can use any one of the method to compress it and store the device. So whenever it required, just it will decompress it, just reverse to perform the operations in order to get the original one. So the f of xy here, the original image before compression. So that has to be reproduced at the receiving side, f cap of x comma y. F cap of x comma y. Then that image compression we have to be performed in the two major category. One is lossless and another one is lossy. So the lossless category, the information should be preserved before and after the transmission. There is no any huge difference or any significant difference between the sending and the receiving. Low compression ratio also. So the low compression ratio means it will not affect the original quality. Lossy mechanism means some of the information, some of the pixels, some of the redundant code has to be corrupted. So that error level above the standard error. So we can't get back the original quality at the time of decompression. So the compression ratio also high. So these two are the broad category of image compression mechanism. So just we have to be see that the trade of information loss versus compression ratio. High compression ratio means the information loss will occur. So that mechanism we have to be simply called as lossy method of compression. Low compression ratio means the information should be preserved before and after transmission. So that mechanism is called as lossless compression method. So here we can use the word data and information. Data and information are not synchronized terms. Data is the meaning of by which the information is conveyed. So here the data, that means the digital image should be represented in the binary format, represent in the data. So that data has to be considered for compression mechanism is here. The goal of the data compression, reduce the amount of data while preserving as much information as possible. The ultimate aim, the objective of the goal of data compression. One is the thing to reduce the size, to reduce the amount of data while preserving as much as information possible without any data loss. If the data loss also, that should be below the standard error. Here you can see the compression ratio. So the data set 1, that image f of x comma y. The another one, the compressed image, data set 2. So n1 that will be linked with the data set 1, n2 that is linked with the data set 2. The compression ratio, compressed and before compression and after compression, the difference you can see, the compression ratio CR equal to n1 by n2. In this way we calculate or we estimate the compression ratio. If the compression ratio is less, there is a chance for information loss. It called as lossy mechanism. Sorry, high compression ratio means the information loss. We lose the data or we lose the pixels above the standard error. That is called as lossy compression mechanism. Low means we preserve the information. So that mechanism simply called as lossless compression method. Then the information theory. Based on this information theory, the compression is going to be achieved. How to reduce it? How to reduce the size? How to reduce the image size without affect the quality means the step 1 what we do, the digital image that should be represented in the data format 0 1 or 1 0 like that, the sequence of code, the coding. So this coding theory provide the way, shortcut way how to achieve the compression. So there are three mechanisms sir, we are going to be discussing here. One is coding redundancy, and another one is interpixel redundancy, and another one psycho-visual redundancy. So these three redundancies, that is the basic things, the basic operations or basic principles that provide the way how to practically achieve the compression method or compression. So the redundancy means you know very well, we know the meaning of redundancy. Some of the coding or some of the message or some of the information or some of the paragraph that should be repeatedly occur many times. The frequency of occurrences is more. The same content should be repeated in many times. So instead of we have to be record, we have to be store all the repeated content, all the redundant content in a dedicated storage space, we use some shortcut method. We follow certain shortcut method to avoid the storage of repeated content, the redundant content. So there is a meaning of redundancy. A simple way, redundancy means the concept, the content, the paragraph or the information or the data that should appear repeatedly, recursively. So here the relevant data redundancy, the relevant data, some of the content that should be relevant with each other, anyhow that it is necessary to present repeated once again like that. So instead of allocate a dedicated storage space for the relevant content, redundant content, the relevant data redundancy or redundant content, we allocate a common place for the redundant content in order to save the storage space. It automatically to reduce the size, it automatically reduce the storage space. At the time of decompression, we have to be get back it. We get back or we have to be substitute the redundant content in a appropriate storage spaces to get the original image. So the relevant data redundancy of D equal to 1 minus 1 by CR. CR means the compression ratio. At least one content or one information or one data set that should appear repeatedly. At least one, many, there is no restriction, but at most there is no restriction, but at least one. So this is the mathematical expression that used to express the relevant data redundancy or D. For example, here you can see if CR the ratio 10 by 1, then we substitute RD, the relevant data redundancy equal to 1 minus 1 by 10 equal to 0.9. 90% of the data in data set 1 is redundant. The data set 1, previous slide, that previous example, we see the data set 1 that linked with N1, data set 2 that is linked with N2. That data set 1, the compression ratio 0.90 means 90% of the data in data set 1 that is redundant. So in this way, we have to be used or we consider the redundant data in order to, we have to be considered or be taken into the account of redundant data for the compression purpose. For the compression purpose. The types, the data redundancy types, that three types: coding redundancy, interpixel redundancy, psycho-visual redundancy. Coding means we have not, we have to be think that will be program statement or any other computer language statement, not like that. Coding means here the binary value, the binary data. So for example, the image has to be represented in a data format, the storage locations, the consecutive storage locations having the consecutively more number of 0 or more number of 1, that we have to be simply called as coding redundancy. So for example, let us consider a 3 cross 3 matrix. So how many total number of storage spaces allocated? 3 cross 3 matrix representation, there are 9 storage locations. In that 9 storage locations, for example, that image has to be considered and converted into the data format. The value is 7 locations having 0, remaining 2 locations having the value 1. Consecutively 7 0, then the remaining 2 will be 1 1, like that. So instead of dedicatedly we have to be allocate the storage space for all 0, we used a shortcut method. There is 1 0 from 1 up to 7 storage spaces, the value is 0. Only one locations we use it, we have to be stored the 0, and that is described as this is shared by from 1 up to 7. Then the remaining 2 locations 1 1, like that. So in this way we reduce the amount of storage space without affect the original quality, without affect the original image. So the coding redundancy, interpixel, psycho-visual, we can see it. Data compression attempt to reduce one or more of these redundant types. Because how the image compression is going to be achieved means the compression attempt to reduce one or more of these redundant types. If the redundancy is null, there is no redundancy after the compression, then that content is ready to transfer through the channel. If there is any redundancies occur, if there is any redundancies occurring after the iteration 1, after the iteration 2, after the iteration 3, step by step, if we can check it, after processing also some redundancy will occur means we go for once again refine it, once again refine it until to come no redundancy. We should repeat it the same thing, the same mechanism. Once there is no redundancy will appear, then it is ready to transmit through the channel. So the decompression side, the same thing reverse. The operations has to be inversely performed in order to get back the original one. The coding redundancy category, to reduce the coding redundancy, we need efficient coding scheme. That efficient coding scheme means symbolically or logically we have to prepare certain table, certain index, how we did. how we are going to be make it a shortcut, how we are going to be represent the repeated content of the coding. So the code, a list of symbol, letters, numbers, bits, etc. Code word, a sequence of symbol that used to represent some information. The example of gray levels. So here the binary code, for example, given here, the binary code symbol 1 comma 5, the length is 3. We fix the common length to represent that coding scheme. So we fill the 3 digits, that one. For example, 0 means not a single one, we make it 0 0 0 like that. We make it the equal for the length of the coding representation. So that is the meaning of, to reduce coding redundancy, we need efficient coding scheme. The code word length, number of symbols in a code word, that should be called as the code word length. To compare the efficiency of different coding scheme, we needed to compute the average number of symbol, that L suffix, the average per code word. We should compare the efficiency of the coding redundancy or coding scheme. For the different algorithm, we use this mechanism. Example, n cross n image. The image is to be represented in the matrix format, n cross n, number of row and number of columns. Rk, the k is the gray level, then I and P, the probability. The average number of symbols, number of bits, that should be calculated by using this formula. The entropy of the image. So the number of bits for Rk, the probability, the redundancy probability. It has to be used to perform the comparison of different coding scheme. So the fixed length and variable length, that has to be assumed here in order to perform the comparison. In order to perform the comparisons. So here they assume the length of the image with the size L equal to 8. Then the value, the k, that should be represented from 0 up to 7. Then another one, interpixel redundancy. So the interpixel. So whenever we try to represent the image in a grid format, we consider the mask, or we consider that one particular portion of the existing image means, we also consider the neighborhood pixels. We also consider the pixels surrounded by the selected one. So that redundancy, interpixel redundancy, implies that, expressed that pixel values are correlated. That means pixel value can be reasonably predicated by its neighbors, through the neighbors. So the f of x, that is the original image, the correlation, the auto correlation here, the histogram is represented in the right hand side, the equivalent histogram is represented in the right hand side of this slide presentation. So the f of x means the original image, the g of x, that is the expected one, or that is the desired one. So to reduce the interpixel redundancy, some kind of a transformation must be applied on the data. In order to perform the interpixel redundancy, some kind of a transformation must be applied on the data. Here, this is the hardware mechanism. You can see the chipset for the original image that has to be converted into the binary image, then the threshold coding value, the run length encoding. Using the group of bits, we make it the, using the group of bit, we make it the coding for the interpixel representation. The psychovisual redundancy, the human eye is more sensitive to the lower frequencies than the higher frequency in the visual spectrum. So the discard the data that is perceptually insignificant. So the human eye, the sensitive is the same way the digital input device that is sensitive to the lower frequencies than the higher frequencies. The visual spectrum you can see here, the compression ratio 2 is to 1. To make it a quantization for these images, the psycho-visual redundancy means you can find the differences in the similarity. Then the key question is the image compression is what is the minimum amount of data that is sufficient to describe completely an image without the data loss, without the loss of information. So based on this, they have to be fixed the standard error. So once we face the value below the standard error, that called as error-free compression, lossless. Above the standard error, that comes under the category of lossy compression and also data or information loss. Here the entropy estimation, what does it mean that the first and second order entropies are different. That means if there is, we find the difference between the before and sending the images at the time of compression and decompression. In general, the difference between first order and higher order entropy estimate indicate the presence of interpixel redundancy, that is need to apply some transformation. Need to apply some transformation. Then the image compression model. Generally the image compression model, here you can see the compression model has to be categorized into two major types, lossless compression and another one is lossy compression. So how this image compression model will carry over? Here you can see the image, the block diagram. The encoder side, the source encoder to perform the image compression based on the information coding theory. The information coding theory that provide the principle of coding redundancy, interpixel redundancy, psycho-visual redundancy. That three redundancy, we have to be eliminate any one of the redundancy or we have to be completely eliminate that redundancy. Once we ensure that no redundancy after that compression iteration, then it transfers to the channel encoder. The channel encoder, noise tolerant representation for carry over the signal purpose. Additional bits are included to guarantee or to protect the data transmission, to perform the error-free transmission. That mechanism is called as Hamming coding. So Hamming coding means you can add the additional bits that will be included to guarantee the detection and the correction of error due to transmission over the channel, that is called as Hamming coding. This is the side of encoder. And another one part is a decoder. The encoder side you can see, this slide you understand more. So the encoder side that comprising the two sub modules, mapper, quantizer and a simple encoder. So the mapper that can be used to perform the reduction of interpixel redundancy. Interpixel redundancy. The quantizer that has to be used to perform to the reduction of that means the psycho-visual redundancy. If we ensure there is no psycho-visual redundancy, then it move to the another part. Symbol encoder. The coding redundancy has to be performed by using this symbol encoder. The same three has to be performed in a reversible manner, in an inverse manner, to get the decompress, to perform the decompress. The decoder side, you can see the symbol decoder that used to substitute the coding redundant. Dequantizer that can be used to substitute the psychovisual redundant. So the inverse mapper. So that can be used to perform the interpixel redundant. So the fidelity criteria for this performance, f of x comma y, the original image, f cap of x comma y, that is the output 1. Subjective and objective, you can look at here. So the based on human observers or mathematically define the criteria. So the criteria has to be specified here. The value and rating and the description. Excellent means an image extremely high quality, as good as your desired one, your expected one. Fine, an image of high quality providing enjoyable viewing, interferences is not objectionable. That means less. Possible, marginal, inferior, unusable. So the image is so bad. That is the human observer make it the subjective fidelity criteria to ensure the compression standard. So the objective, so that the thing has to be represented mathematically. Root mean square error, mean square signal to noise ratio. So it has to be ensure the error level. It has to be used to ensure the error level. Lossless compression, the compression and decompression without any impact on the original quality of the image in order to reduce its size. Just you have to be see the difference. F cap of x comma y minus f of x comma y, there is no significant difference. There are different types of lossless method, algorithm or mechanism or coding technique. One is called repetitive sequence encoding. So that should be respectively according to the order. It has to be branch wise listed here. The first one is the run length encoding. Example here, repetitive sequence encoding. Then the statistical encoding, Huffman algorithm, arithmetic algorithm, and LZW. Lossless predictive coding, discrete pulse code mechanism or model, then bit plane encoding. So all this comes under the heading of lossless method or lossless image compression. This image has to be taken from the paper Image Compression Technique. The source of this picture I represent below the diagram. The lossy method, you know very well, lossy method, the high compression ratio, the information become loss. So that mechanism has to be respectively classified in a branch wise. Block truncation coding, lossy predictive coding, transform coding, subbond coding, fractal coding, vector quantization. So all these are comes under the heading of lossy method. That means the data loss is huge or above the standard error. Above the standard error. So the lossy compression, you can see, transform the image into some other domain to reduce the interpixel redundancy, image input. The image input n cross n or n cross m or m cross n. So construct the sub image, forward the transformation, make it quantization, and the symbol encoding that produced the resultant one compressed image. So the compressed image is the input in order to perform the decompression. The same thing we make it the inverse manner. Symbol decoder, inverse transformation, then merging the sub images. Merging the sub images. The error free compression mechanism on entropy based encoding algorithm that has to be listed. Variable length coding VLC, run length encoding or run length coding, differential coding, predictive coding, dictionary based coding. All this we can make it ensure the error free compression mechanism. Then the image compression standard. The image compression standard, we make it here. Work on binary image compression standard was initially motivated. So different types of documents, the different types of digital images, different types of image formats that has to be represented in a standard format in order to reduce the original size without affect the quality of existing image. So this is a short and brief description about image compression. Actually, the image compression has more or many number of concept and algorithms according to the exam point of view as per your syllabus guidelines. A simple thing, a simple manner, I have to be explained by using minimum number of slides just to convey the concept or principle behind the image compression. Okay, students, thank you.